All right, so today we are going to study how to draw a phasor diagram for any circuit which is resistive, capacitive, or inductive. On a phasor diagram, we will study how to present voltages and currents with the same frequency but different amplitude and phase. For example, just a review from last lecture, we studied a waveform. Let's say we have a time domain signal and we need to draw the phasor diagram for the signal, right? So the first thing we need to do is convert this time domain signal to frequency domain. And we studied different representations last time. So if I have to represent this in phasor representation, I can write this 5 is this 5 here, this 5 is the amplitude or the magnitude, and this 20 is the phase. So I can write this at 5 angle of 20 degree. And this is the phasor representation. If we want to represent this using exponential representation, we can write this using 5 e raised to power j20. This is the exponential representation. And if we want to write this in rectangular form, we can simply write this by 5 cos of 20 degree plus j sine of 20 degree. And this is the rectangular form. Now I have to draw the phasor diagram for this particular voltage, right? So what I do is that I will do a polar representation for this. 5 is the magnitude and 20 is the phase. So I will draw 5 as a magnitude and 20 degree as the phase for this particular voltage, V1, right? So let's say I have another voltage, which is V2, which has a magnitude of 10, but an angle of, let's say, minus 40 degree. So I can write this one as minus 40 degree as an angle and 10 as a magnitude, right? And this 5, just remember from last lecture, is 5 is the magnitude, and which can be calculated like this one. So x and y coordinates are represented here, which can also be found out using 5 cos of 20 degree plus j sine of 20 degree in order to find out the rectangular coordinates on x and y axis, right? And for V2, we will have these two rectangular coordinates. So this is how you can draw phasor diagram for any voltage sources. However, if we have a circuit now, which is a resistive circuit or an inductive circuit or a capacitive circuit, and we need to draw the phasor diagram for that particular circuit, how we can do that. Let's say I have a circuit which comprising of only a resistor and a voltage source, an AC voltage source, Vs, right? So on, this is, let's say, my Vs representation, voltage representation, and the current that is flowing through this circuit can be represented by R. We know that for a resistor, the voltage Vs and current are in phase with each other, which means that the theta will be 0, right? However, if we have a circuit which is pure inductive circuit, inductor, we know that in an inductor, the current lags the voltage by 90 degrees. So on the phasor diagram, we can represent voltage as a vector like this one, and the current can be represented by an angle 90 degree, which is actually the current is lagging the voltage by 90 degree as looking into this phasor diagram. This is a pure inductive circuit. So current lags the voltage by 90 degrees. So theta is 90 degrees. For a pure capacitive circuit, we know that the current leads the voltage by 90 degrees, and this can be represented as current IC. I'm going to write this IL, this is IR, as plus 90 degrees, right? So these three, if a circuit is given to you, these three are for pure resistive, pure inductive, and pure capacitive circuit. However, the circuit can comprise of any components, any resistive or inductive components. We could have a circuit which is not pure inductive, but a resistor is also in series with an inductor. In that case, let's say we have a circuit which has an inductor and a resistor. So now inductor is not a pure inductor. It has a resistive component there as well. So now definitely the current lags the voltage by 90 degrees, but by some degrees, but it is not going to be 90 degrees now, right? So the phi or theta value is going to be different, which is not going to be 90 degrees. So the phase will be between 0 and 90 degrees, right? This is going to be IL. It's going to be somewhere between 0 and 90 degrees. Similarly, if we have a capacitive circuit, right, which has a resistor as well, resistor and a capacitor, and we draw the current, this is how it is going to be represented. Just again, not going to be 90 degrees, but it's going to be somewhere between 0 and 90 degrees. Let's say if we have a circuit which has both resistor, inductor, and capacitor. If we have a circuit something like this, connected to a voltage source, inductor, resistor, and a capacitor, right? So the capacitor here is a pure capacitor. However, the inductor is not a pure inductor. So when we draw, this is the source. When we draw the phasor diagram, the capacitive current is definitely leading by 90 degrees. However, the inductive component IL will have some phase, which is not 90 degrees, but it's going to be between 0 and 90 degrees. And what is that value? We will have to calculate based upon the resistor and inductor value. So we'll solve the circuit and we'll find out what is the phi value for this particular circuit, right? Okay. So now we are going to study, for example, this is a circuit given to you. There is a current source. We have a resistor, inductor, and a capacitor connected in parallel with each other, right? So for this particular circuit, we have to find out what is its phasor diagram. So the voltage V here, can be written as Vm angle 0 degrees, right? So let's say it's not given to you. The source is IS, which is the current source. And we have to find out what is the source current for this particular circuit. We have to find out what is the inductor current, IL and IC, and we have to represent it using a phasor diagram, right? So these all three are pure resistor, inductor, and capacitor circuits. So even without solving this one, we can draw the phase diagram. Without even solving this one, I can draw the phase diagram by looking into, this is voltage. Let's say this is voltage, which I represented just now. The IR can be represented like this one. IC, which is the capacitor current, can be represented with a leading current by 90 degrees, and an inductor IL can be represented as lagging current from 90 degrees. And I'm assuming that IL is greater than IC. So again, it depends upon the values of the inductor and capacitor. Now, what is IS in this case? So IS is, you can find out the total current. You can find out total current IS by simply adding up all three currents using Kirchhoff's current law. And please recall that voltage is equal to the impedance times the current. And we can replace this one by its values. Impedance of the inductor is j omega L, while the impedance for the capacitor is 1 over j omega C. And we derived this also in our previous lecture. So let's say our source IS, as we represented, has an angle Vm, magnitude Vm, angle 0, plus Vm, angle minus 90 degree. So what I have simply done is that this j in the denominator, when it goes up, it is actually minus j, which is nothing but minus 90 degrees, right? And which is represented here at IL, plus Vm omega C angle 90 degrees, right? And simply plus j here, when goes up, is actually angle 90 degrees, right? So IS, let me change the color. So IS will be some angle. We have to calculate using all these values. We have to calculate what is going to be IS, but IS is going to be somewhere here, depending upon what is the theta value, right? Please note that what I have done is that I have done the magnitude here. So this value is the same as going to be this value, because the resistor IR and IS will have the same resistive component, right? Because only the J part, or the imaginary part, was going to be contributed by the capacitor and the inductor. So that's why we will have we will have exactly the same value for the resistive components. So R plus JX, which is going to be the solution of IS, is going to be something like this. We should also note that we can write IS as, from solving this equation, IS 1 over R plus J omega C minus 1 over omega L voltage. So if we make omega C minus 1 over omega L in this equation equal to 0, omega will be 1 over the root LC. And in this case, we see that IS, which is the source current, will be in phase with the voltage. If we have this condition, omega C, if we have this condition fulfilled, then we see that IS will be in phase with the voltage, given this condition, right? Also, looking into this diagram, we can also see that IL is greater than IC. So if I have to find out what is IL plus IC, it is going to, on a phasor diagram, it is going to be somewhere here, IL plus IC, the black line, the black vector. All right. So now let's say a circuit is given to you which has three components: resistor, inductor, and capacitor. However, instead of being in parallel, they all are in series with each other. For any circuit given to you and the values of inductor, capacitor, and resistor are given to you, what you have to do is that you have to, and if you have to draw the current and voltage in a form of a phasor diagram, you need to calculate the value of current, right? You need to know what is the value of Vs. So in order to find out the current value for this one, the first thing you have to do is that you have to calculate the impedance. You have to calculate the impedance for the inductor. For the resistor is the same, impedance and resistance is going to be the same for inductor and for capacitor. So the first thing is calculate its impedances. So what is going to be the total impedance? It's going to be R plus J XL and minus J omega C, right? So how will you calculate VL and VC? It is nothing but, and I have just mentioned it last here, that this is the value of impedance for the inductor, the J omega L. So XL is equal to, this is the impedance, ZL, this is the impedance for the capacitor. So ZXL is going to be omega L, XC is going to be 1 over omega C. So we have to calculate these values. And again, for this case, if you need to calculate the value, you need to know what is the frequency, which is going to be 2 pi f, right? So I will let you do this problem and calculate the value of impedance. After you calculate the value of impedance, it's going to be in the form of x and y coordinates, something like x and y, something like this, right? This is x and y coordinates. In order, from this one, you can calculate the current by V over Z. You can convert this one using to the phasor representation. You have the phasor representation here. Let's say you have a peak value here and an angle 0 degree. You can have this value, and then you can find out what is your magnitude and what is the theta value. Once you have this value, once you have this value calculated, you can easily plot this on a phasor diagram, right? So you can easily plot this, whatever is the value here, you can plot this theta z here, and this is going to be your magnitude for this vector. For any circuit, this is the way you have to solve this phasor diagram. Thank you very much.